أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Assalamu alaikum wa rahmatullah. I welcome you all to the channel today. Today we will solve problems related to average acceleration, and I named it problem 1. We have A part of the problem and the B part of the problem. They are pretty simple to begin with. Let us now read the problem. A part of the problem said a robot named Fred is initially moving at 2.20 meters per second along a hallway in a space terminal. It subsequently speeds up to 4.80 meters per second in a time of 0.20 seconds. Determine the size or magnitude. Size and magnitude are synonymous. Okay, the size or magnitude of its average acceleration along the path traveled. Okay, before we begin, we have to identify the parameters we are given. Let us bring them out. We are told that this robot named Fred is initially moving initially, so this is our initial velocity. It means this is our v sub I, and then it subsequently speeds up to, this is our final velocity v sub f, and then the time it takes, it has to take time for the velocity to change from this value to this value, and the time it takes is this is our time t. Now the question is, how can we calculate our average acceleration? Our average acceleration is our target variable. Okay, let's see that quickly. We write a solution, okay, then a uh, a our initial velocity v sub I from the problem is 2.20 in meters per second. This is our initial velocity. Our v sub f, the final velocity, is given as 4.80 in meters per second, and then the time it takes for the velocity to change from this value to this value is t equals, or I prefer, let us call it delta t, and this is equal to 0.20 in seconds according to what we are given. Now our average acceleration, how do we get this average acceleration? From here we write the formula. Don't forget, a acceleration average is equal to change in velocity divided by the time interval taken by the velocity to change, and this is equal to our v final minus v initial. Whenever we say change in velocity, we mean v final minus v initial divided by the time it takes to change. So our v final from the problem 4.8, so we have 4.8 minus v initial from the problem 2.0, so we have 2.20, 4.80 divided by the time interval 0.2 second. This everything here is in meters per second, the denominator in second. So your answer, how do I do this quickly from my calculator? From your calculator, I will show you. You simply open bracket. First open bracket, press this one minus this one, close bracket, then divided by the denominator here. So as quickly as possible, look at it here. I am going to open the bracket. This is open bracket. Then I will say final velocity, which is 4.8, then minus my initial velocity 2.2, then I close bracket. If I close bracket, then I will divide the result by my time, which is 0.2. Okay, if you do that, press equality sign and look at your result from the calculator. It gives 13. As you can see, this is 13. So your answer is 13. Then remember, the quantity you are calculating is acceleration, and the unit of acceleration is meters per second squared. So the average acceleration is 13 meters per second squared. Okay. um B part of the problem, we are going to solve the B part of the problem, but before that, let us see the problem. It says a car traveling at 20.0 meters per second. When the driver slams on the brakes and brings it to a straight line stop in 4.2 seconds. This is the time it takes to slow down. What is the magnitude of its average acceleration? Okay, now this velocity that is mentioned first is our v sub I. This is our initial velocity. Then what is the final velocity? Remember the cases we considered in the class. I think about 5 cases. Whenever you are using equations of uniformly accelerated motion. So they said whenever an object comes to rest, or is brought to rest, or it is stopped, it means your v final is 0. And then look at this one, the time it takes. This is our delta t. I think we can solve this one even right here. So our average acceleration, a sub average, okay, this is a sub v, a sub average is equal to v final minus v initial divided by the time interval, the time taken. Our v final is 0 because it is brought to rest, so we have 0 on top minus our initial velocity. Look at, we were given 20, so this is 20.0 divided by the time taken, 4.2. So we have 4.2 here. Everything here in the numerator is in meters per second, and then the denominator in second because it is time. Again, take your calculator, open bracket, 0 minus 20.0, close bracket, press the division operator. Now press the denominator, 4.2, press the equality sign now, and you see the acceleration is minus, you have a negative acceleration, 4.76 in meters per second square. And this makes sense because the object is slowing down, the car is slowing down. Whenever a particle slows down, its acceleration is negative. Here in the initial problem, remember they said it speeds up here, cool? It speeds up, and because it speeds up, we expect a positive acceleration. You see, positive acceleration. And in the second case for B, the car slows down until it is brought to rest in 4.2 seconds, so we expect a negative acceleration. Each of these problems should not take you more than 10 to 15 seconds to solve. Okay, what you should do is identify your initial velocity, your final velocity, and the time taken. Then you take your calculator, open bracket, final velocity minus initial velocity, close bracket, divided by the time taken. This will give you the acceleration without writing anything, by mere remembering of the formula that is sub average equals v sub final minus v sub initial divided by time interval. Then you check the problem, where is your v sub final, where is your v sub initial, where is your time taken. Okay, then you open bracket and say v final minus v initial, close bracket, divided by the time taken. This will give you the average acceleration. I hope this is clear. Thank you for watching. Assalamu alaikum wa rahmatullah.